All right, what I'm going to do, I'm going to start you off. I think they started you off. They made a lot of assumptions, okay? And they should be able to. It's a pre-calc class or book. They should be able to make assumptions that you know how to do certain things, all right? I don't always make those assumptions, all right? So what I did is I found some, I call pre-examples that we're going to do with fractions. Not everybody's super great with fractions, so I thought I'd do a couple examples before we do the one that's in the book, the first one in the book. Actually, we're going to skip example 1 in the book. We're going to go right to example 2. But here are some pre-examples, all right? So pre-examples, for lack of a better term. All right, here we go. I'm going to ask you to solve for x, and it's going to look something like this. 1 over 6x squared equals 1 over 3x squared minus 1 over x. All right, and you got to solve for x. So what do you think? How would you approach this? This is equal sign right here. Kind of looks like a minus, but it's an equal sign. Let me ask you this question. What don't you like about this problem? Not just because it's a math problem, okay, but it's what? I heard it. Fractions, exactly, okay? So it'd be really nice if we didn't have to deal with fractions. Would you agree? So let's make this not have fractions in it. Any ideas? Say it. By 1? By 6? Keep going. You're on the right track.
Oh, the common 18? No. Well. Oh, yeah, they all have to do, like, you know, the least common.
I love this. I can see the steam coming off your head that you're thinking so hard. That's good. You said multiply by 6. Why'd you pick 6?
Oh, because everything can go into 6.
Okay, but there's something else here in the denominator. What is it?
Oh, squared.
Okay.
Oh, you can do 6x, right?
Squared. Yes, you got it. Yeah, because you got to pick a common, basically least common multiple, okay? The smallest number that will divide, or these will divide into, okay? Find a number that this, and this will all evenly divide into. So 6 is one, isn't it? Right? And then what else? X squared is another one. So what I'm going to do is I'm going to multiply by 6x squared here, 6x squared here. Now, why am I allowed to do that? Because I can do whatever I want to one side as long as I do it to the other side. So I decided to multiply this side by x squared. So what do I have to do to this whole entire side? Multiply that by 6x squared. All right, I just separated it. Again, I watch these videos where this guy puts one big parentheses and just one 6x squared over here. Then he distributes it. I'm thinking, oh, I know what you're doing. I get it. And that makes sense. But students don't think like that, okay? I think it's a lot easier just to see it as multiply everything by 6x squared. Yes? All right. So why do we do that? What's the purpose in doing that? It's because each one of these things divides into 6x squared evenly. So guess what? They're all going to cancel out. Exactly right. And then we got rid of our fractions. That's what we wanted to do in the first place, isn't it? All right, so let's do that. So what happens here? That cancels, and I'm left with a 1. Oops. I thought I'd change that back to white. Let's make this white. Okay. So that cancels, equals. What happens here? The x squared cancels. That 3 divides into the 6 how many times? 2. And then 2 times 1 is 2. Starting to look better already, isn't it? All right, what do we do here? This x cancels what? Just one of these x's, right? Because that's an x squared. What are we left with? Minus 1 times 6x minus 6x. Now it's super easy. Now we can solve for x. Agreed? So, I don't know. What do you want to do? Let's add the 6x to this side. Let's subtract a 1 from this side, divide by 6, so x is 1/6. Pretty easy, right? Yeah? Only reason I did that is I didn't want to put this over here and divide by -6. That's the only reason. All right? Either way you do it, you still get 1/6. Yes, 1 minus 2. Did I do that right? Yeah. Yeah, move this over here, took the 1, moved it over here. 2 minus 1, yeah, is 1. Pretty basic, right? Yeah. These are kind of basic ones, and then we're going to do one that's a little bit more complicated, all right? Here's another pre-example, and then we'll do a real one. So we'll call this part B. So it's 1 over x minus 2 plus 1 over x squared minus 7x plus 10 equals 6 over x minus 2. Now this definitely took a step further, what we just did, but it's the same basic principle though. All right, looking at this, to me, just smacks me in the face what I do first. What do you think I do first? Okay, get rid of the fractions, but one of these fractions looks a lot weirder than what we did on the other example. It's this one, right? So what does that look like we should be able to do to it? Well, not just solve. What is it? Give me one word. We've been doing this. Factor, right. We've been saying factor like 1,000 times this in the last couple lessons, haven't we? All right, so we're going to factor this. All right, so let's try that. So what is that? Should be able to do that, right? X and x. They multiply to be positive 10, add up to be negative 7. What numbers are you going to use to get 10 and 7? 5 and 2. But you're not going to use a negative and a positive because they have to multiply to be positive. So they have to be both be either negative or positive. If they add up to be a negative 7, they can't both be positive, so they have to both be negative. So this is going to be what? Minus 5 minus 2. Everybody see that? All right. That's basic factoring. We're ready in my Algebra 2 class to take a test on that, and that's some of the easier stuff that we did. So I'm just going to put it right there just to make it a little easier so I don't have to rewrite everything. Now, let's do what we did on the last one. It's a little bit different because you got these binomials, right? This is a binomial. This is a binomial. So we want to get rid of the fractions. So what do? Multiply by something that each of these can divide into evenly. Will that get rid of the x minus 5? So it'll get rid of the x minus 2's. So what are we going to multiply by? Not just x minus 2. We're going to multiply it by x minus 2 and what else? X minus 5. That's right, because we want it to cancel out with this. So we're going to multiply everything by x minus 2 times x minus 5. Do it to this. Do it to this. And do it to this. Everybody with me? Okay. So how does that help? It helps a lot. Okay, this is a huge, huge part of this problem. It's the biggest part of this problem. Then it makes things a lot easier for me. So if you multiply this times this, or divide, sorry, that cancels out with that. What are we left with? X plus 5 times 1, which is just x plus 5. Is it minus? It is minus. My bad. Thank you. I don't know why I did that. Thanks for catching that. Okay, x minus 5. Thank you. That still is a plus. What about here? Wow, this all kinds of stuff go, right? The x minus 2 goes, the x minus 5 goes. What are we left with here? Just a 1. So that made it nice and easy. What about here? What cancels out here? The x minus 2 cancels. Now, let's do a little bit in our head. It's 6 times x minus 5, 6x minus 30. And now, super easy. Agreed? I'll let you do that on your own. I don't need to go through every step, and it's going to be that. And that's your answer. That's x. Remember, these say solve. Solve for x. All right, that was warm up. All right, now what we're going to do is the problem. Really, this problem's really not, well, yeah, it's a little bit more involved than the other one, but it's the same idea. It's the same exact idea. So I'm skipping example 1, and we're going to go to example 2. This one is in the book. Okay, it says to solve. They use a this time. I guess we'll use a. So this is a squared minus 5 over a squared minus 1 equals a squared plus a plus 2 over a plus 1. All right. Now, you should have a decent idea of at least where to start. Do you? Yeah, definitely that, okay? So let's factor that right there, okay? And this is a difference of 2 squares. Remember how to factor difference of 2 squares? A here, this is plus, this is minus, 1 and 1. So that's factored. I'm not going to sit there and teach you that whole step. We've done that before. So I'll replace that with this. Oops, there we go. Let's move this over just a tad. Give me some room. There we go. So can we factor this right here? A squared minus 5. Is that a difference of 2 squares? No, because you're not squaring anything to get a 5, are you? So we can't really factor that. What about this? Looks like we should be able to factor that. Can we?
Yeah.
We can?
Yeah. Yeah.
You don't know? Well, think about it. Instead of just saying yes or no. Say what? Yeah, but this has to multiply to 2. It has to multiply to be 2 and add up to be 1. And they're both positive. The only choices I have are 2 and 1. Is there any way I can get a positive 2 and a 1 to add up to a 1? No. So I can't factor that. So no, is your answer. Okay, so, but what do we got to do? Well, you say both answers to a yes or no question, you're bound to get it right with one of them. All right, I'm just moving this so I have some room. So what do we want to do here? What's this A? This A is over what?
1.
It's over 1. Okay. And let's change this to red again. All right, here we go. So now we want to get rid of the fractions. It's basically the same step as what we did on the last problem. What's our common denominator? Least common multiple, whatever you want to call it. It's not just a plus 1. It's a plus 1 times a minus 1. That's what you're going to multiply everything by. How do you know that? Because I got to get rid of this a plus 1 and I have to get rid of the a minus 1. So if I multiply them together, they're going to cancel. Everybody got it? So now this is where it gets a little complicated. But the idea is the same exact thing as we did on the last problem. All right, so I'm going to multiply this by a plus 1, a minus 1. Then I'm going to take this. I have to slant it up here a little bit. I'm going to have to multiply this by a plus 1 and a minus 1. Then I'm going to have to multiply this by a plus 1 and a minus 1. Should have left me some more room here, but I didn't. That's okay. Let's cancel some stuff out before we do anything else. So let's take this middle one right here, this thing right here. I got an a plus 1 on top and on the bottom, so that cancels out. A minus 1 on top and bottom, they cancel out. So you're going to be left with a squared minus 5. Let's cancel some more stuff out. There's only one more thing we can really cancel out. What is it? The a plus 1. So this a plus 1 goes with that a plus 1. Everybody with me? All right, let's write it out nice now. So it's going to be a times, let's see, did I Yeah, I did. If you wanted, if you're going to multiply all that stuff together, you already know what a plus 1 times a minus 1 is, don't you? Might as well write it like this. So it's going to be what? A squared minus 1. See what I just did? Just multiply those together. It doesn't. Nothing cancels out because you had a 1 on the bottom. Plus, what about this? Everything canceled out. So we still had a squared minus 5 on top equals. What happens here? No, we're not going to put it over anything. You're not going to have any denominators at all. Okay. So, let's do the multiplication right now, and then we'll do it off to the side, and then we'll chuck it in right here. Okay, because we're going to have to multiply those together anyway. So what do I have? A minus 1 times a squared plus a plus 2. So you just have to do some distributive property here, right? Everybody okay with that? So take the a and multiply it through by everything. So that gives you a cubed plus a squared plus 2a. Take the minus 1 and distribute it through. So that's a negative a squared minus a minus 2. We okay with that? Now, you might have to write it over again, but, oops, if I could, see, I was just bragging. There we go. So that's that. So, if you wanted, let's do this. Yeah, I'm just going to put it right here. Is that all right? You just might have to rewrite a bunch of stuff, but I can just move stuff over. Isn't that nice? So what's this going to be? A cubed minus a. All right, so there we go. Let's do some math, and let's solve for a. First thing I see is an a cubed here and an a cubed here. What's going to happen to that? Cancel each other out. Okay, you subtract an a. Technically, you subtract an a cubed from both sides. Okay, they cancel out. And then, what else we got? Oh, we got a minus a. See that minus a and this minus a? I'm just going to scribble it. So that's going to cancel out. Because it's the same exact thing on both sides. I added an a. I added an a to both sides. Okay? What else can we do? A squared. This a squared and this a squared. What happened? Well, actually, let's do this. This a squared minus this a squared is 0. All right? And, yeah, let's start bringing some stuff together now. I got an a squared. I got a 2a over here, so I'm going to move it to the left-hand side. What's that going to become? Minus 2a, so I got rid of that. And then I just got this minus 2. How do I get rid of that? Add it. Add it to this, and I get minus 3. And that equals 0. Well, no, you got to solve. You got to solve for a. Have we solved for a yet? No. That was the bulk of it. Would you agree? I mean, it wasn't hard. The arithmetic wasn't hard. You just got to keep everything straight, you know? You got to make sure, how do you move stuff over? What cancels out? You just got to be careful. It's a little meticulous. You know what I mean? All right. So what about this? You can solve for this several different ways. This one does factor nice and easy. Do you realize that? So I put an a here, a here. So this times this has to be negative 3, and they have to add it to be negative 2. How about negative 3 and positive 1? Because when you add them up, it's got to be a negative 2. If this was positive and that was negative, that would be a positive 2. Okay, so it has to be minus 3 and positive 1. Now look, both of these things multiply together to equal 0. We've done that a million times at this point. So what's a? 3. And what's a over here? Now, you got to be careful though. You can't be super happy that you did the whole problem, circle them both, and we're good to go. Because remember, we had denominators here, didn't we? So I said that a is equal to negative 1. Can a be equal to negative 1? Look at the original problem. Let me try to get rid of these crossing out marker things. Remember our original problem? Well, this wasn't original, but it was close to it. Right? It was just factored. Can a equal negative 1? Why not? Exactly. It would put a 0 in the denominator. Okay? So if a was negative 1, this would be a 0. Can you have a 0 in a denominator? So can a equal -1? No, it can't. So you have to get rid of it. It is not one of our solutions. Even though mathematically it came out to be one of our solutions, it's not one now. So that's your only answer right there. So if you would put a 3 in for the A, the original problem, those two sides would equal each other. We're not going to do it, but if you wanted to, you had some spare time, feel free. Make sense? So that was the only example for that first part. What did I call the first part? Rational equations. Do I want to start this? I don't. Let me see. This is another pre-example. I'll do that, and that'll probably take us. I don't even know if I have time to do this, but at least I'll get started. Everybody still awake? With me? Excited about learning this stuff? This is called partial fractions or decomposition. And actually, we're not doing. Yeah, we are going to do the decomposition. All right. It's not one of the titles in the book, but it's called decomposing fractions into partial fractions. So there was a lot of words to the title of this lesson. They could have thrown some more in there, but they didn't. All right. So, but that's what we're doing. We're decomposing fractions, and we're going to turn them into partial fractions. You have no idea what I'm talking about right now, but what I'm going to do is go backwards. What I'm going to do, again, this is a pre-example. This is just something that I came up with. It's not in the book. So let's start at the very beginning. What if I wanted you to add fractions together? I didn't write this down, but let's do something super easy. What if I go 3/4 plus 2/3? And I ask you to add fractions together. Let's go back to the beginning. What's this? 4th grade, 3rd grade maybe? I don't know. Something like that. So what do we do to add fractions? What's very, very important that we have? Very good. Common denominators. That's what I wanted to hear. How do we find the common denominator? Well, you find a number. It's the least common multiple, right? It's the smallest number that 4 and 3 will divide into evenly. And what is that? It's 12, right? It's 12. Now, there are bigger numbers that 4 and 3 go into, right? But you want to find the smallest one, the least common multiple. So 12 and 12. Now, what did you do to this 4? What did you multiply it by to get 12? Multiplied it by 3, didn't you? So what do we do to the top? We multiply the top by 3. That gives us 9. All right? What do we do to that 3 to get to this 12? Multiplied it by 4. So what do you do to the top? Multiply the top by 4, you get 8. Now, since you have a common denominator, we can put everything over that one denominator, and now we can just add the top. 9 plus 8 is 17. It doesn't reduce. You don't even need to change it into a mixed number. It's fine like that. Everybody with me? Okay. Now, that was a pre-example. All right? I'm going way back. Yeah. Oh, in 1st grade. I'm sure you didn't do that in 1st grade. But 3rd or 4th grade, you probably did that stuff. I don't know. Never taught 3rd or 4th grade, but I'm just trying to think back to my childhood. And when did I start crying every day going to school? Probably when I was adding fractions with not common denominators, okay? So here we go. Let's do this one. Now we jump up into algebra, and we're kind of going to do the same thing. So you're not solving for x here. Okay, see the difference? We're not solving for x like we did on the other one. You are working with fractions, with rational numbers. Rational numbers or anything you can make into a fraction. And so we have to add these. It's very similar to the steps that I took here, except we have variables. We got x's. There we go. So how did we find that common denominator? You could always just multiply those two things together, couldn't you? All right. It doesn't always give you the least common multiple, but at least it gives you a common denominator. All right. What about here? Think of it like this. Don't think of them separate. Think of them grouped together like that. No? What if this was your 4 and this was your 3? What did you do to 4 and 3 to get that 12? Multiply them together, correct? So what could you do here? Multiply them together. So what's your common denominator? No, let's just write it like this. X plus, I tell you what, let's not do two separate ones. Let's just do it like this. All right, let's just make one. Let's just do the one, okay, instead of two separate ones. So what's my common denominator? X plus 4 times what? X plus 5. Okay? Now, what did you do? What did you do to this x plus 4 in order to get that whole entire denominator? What'd you multiply it by? Look, what'd you multiply that 4 by to get to 12? 3. All right? So you multiply the bottom and the top by 3. What did you multiply this by in order to get this whole entire denominator? X plus 5. That's right. So I multiplied this by an x plus 5. So guess what? I'm going to multiply the top by an x plus 5. See it? Do you see how it follows from a basic fraction? Same exact thing. It's not exact, but it's pretty much the same thing. What about this? What did I do to x plus 5 in order to get x plus 4 times x plus 5? What did I multiply that by? X plus 4. And what do I do to the top? Multiply that by x plus 4. Okay? Right with me? I don't know. You don't seem so confident. Well, I got 3 guys right in that same row right there that seem confident. They're so confident they can fall asleep during my lecture. So they must have this down pat already. I'm sure of it. So now, what do we do here? I found my common denominator. What did I do? I multiply these two together, didn't I? Everybody see that? To get the 9. So what am I going to do here? I'm going to multiply those together. So what do I get when I multiply that together? Negative 2x, thank you, minus 10. Very good. Everybody okay with that? All right. And then, what do we do to this? Multiply that. That's a positive 5. Always make sure, don't let that get lost. Because if that was a negative, you'd have to distribute the negative through there, okay? It's a positive, so it's fine. So what do I do? Plus 5x plus 20. Let's see what we get. Our denominator, we're just going to, do they keep it like that? They actually do multiply it through. All right, so if I multiply that through, what would I get? X squared plus 5x plus 4x, which is plus 9x plus what? 20. Now let's add some like terms here. Do the x's first. Negative 2x plus 5x is 3x. And then negative 10 plus 20 is plus 10. And that's the answer to that addition problem. But that's not what we're doing in here. All right? Anybody want to take a wild guess what we're going to do with this? It's called decomposition into partial fractions. Like right here. See this 9 over 12 plus 8 over 12? That'd be considered a partial fraction. You guys listening? Okay, this would be considered a partial fraction. We took this, we decomposed it into this. So guess what we're going to be doing? I'm going to give you this fraction. I'm not going to do it today because we're out of time. We'll do it first thing on Monday. But watch this. I don't know if this is going to make you feel any better or more scared, okay? But we're going to take this, and I want you to decompose it into a partial fraction, which means we are going to change this answer into the original question. So we're going to take this, and we're going to make it look like this. Okay? So that's what the goal is. All right. When it says partial fractions, this is a partial fraction. See how there's two separate fractions with a plus in between them? This is one big old fraction. All right. This is a partial fraction. We're decomposing this into that. And there's a series of steps, a series of things that we have to do to be able to do this. So that's what we're going to do on Monday. You do? You should see at least a little bit of it, right? What are we going to do? What are you going to do to that? Just put it over there? Give me a word. Give me a math word. No, I'm asking you a question, meaning you're wrong. So take back the high five. So look. So what do we do to this to get to this? Yeah, you factored it. Okay? So that's our first step. But then you got to figure out what's that going to be and what's that going to be. Here, I'll give you a hint without doing the whole entire thing. All right, so I'm going to put x plus 4 right here plus x plus 4. Oh, plus 5. Thank you. All right, so watch what we're going to do. This is just a hint to what we're going to do. We're going to make that an a, because see, I don't know what this is yet, do I? Right? If I just start with this and wasn't told that that's my answer, there's no way I would know that's -2. So what am I going to put? I'm going to put an A in there. And again, I don't know what that is either. So guess what I'm going to put here? A B. Then, excuse me. Then what I'm going to do is a series of steps to solve for A and then solve for B. And then I can put it like this. Does that make sense?
Yeah.
Yeah, kind of. All right. Enough of that. I'm sure you can't wait till Monday to come in to learn how we get A and B. All right? But you're just going to have to wait. I'm sorry. There we go. All right, so no homework tonight. We didn't finish the lesson, so I'm not going to assign any homework, even though it might say, actually, it says on the lesson plans we're going to do what? 3-5 or whatever it is, 4-5. What chapter are we on anyway? 4. It says 4-5. So don't do 4-5. Everybody hear me? Don't do 4-5. We're on 4-6. I have not put that on the lesson plan yet, but that'll be on there by Monday. All right, have a good weekend.